We're going to look at impulse now. So to understand impulse, we're going to ask this question. How can we reduce an object's momentum to zero? In order to do this, we must apply an impulse. So an impulse is what changes the momentum. So hopefully you're writing down the definition now. So impulse is the change in momentum. Okay, mathematically speaking, it's the product of force and time. Product means you're going to multiply. So that's what we're going to notice when we write out our formula. So the mathematical relationship for impulse is I is equal to force times time. So the variable is a capital I equals capital F and small t. So I stands for impulse. The units are the same as what momentum would be, so newtons per second or kilograms times meter per second. F stands for force, like we had in Newton's laws, so force of an object. So we learned the unit is newtons, capital N, make sure it's a capital. Time will be in seconds. So if time is not in seconds in a question, you have to convert it to seconds because we've got meters per second there. Just reminders, we can rearrange that formula. So if I wanted to start with that formula and I want to divide off the F to solve for time, this would be the formula. T is equal to I over F. I also have I is equal to FT, and if I wanted to solve for force now, I would divide off the time. So force would equal to I divided by T. So those are the two other ways that formula can be written. Okay, so let's look at an example here. An object has a momentum of 1,000 kilograms times meters per second. So it actually gives you momentum. So we need to make the connection between momentum and impulse. What impulse is required to bring it to a stop? Well, if the impulse is going to be the amount required to stop the momentum. So it's going to be the same amount. So let's say will be the same as the momentum. So it stops. So the idea is to stop that. So 1,000 kilograms times meters per second would be that. So if it stops, you need the same amount. Okay, B, how much force is needed if it stops in 1 second? So now we're going to use our impulse that we found, and we can figure out the force required. So in this case, we need to solve for force. So we're using our force formula now. We've got it rearranged. So force is equal to impulse divided by time. So the impulse for it to stop was 1,000 divided by 1 second. So just still 1,000. Units for force, capital N for Newton. What if we change the time period each time here? How much force is required if it stops in 2 seconds? Force is equal to impulse divided by time. So 1,000 divided by 2, it would change it to 500 newtons. What about 4 seconds? If we have force is impulse divided by time, 1,000 divided by 4 now, 250 newtons. And the last one, in 10 seconds, what would be the force? So it would be impulse divided by time, which is equal to 1,000. Now we're dividing it by 10, so it would be 100 newtons. Now in your homework, you may also have questions to solve for I or for T. What is the function of the airbag? So of course, you know it's to protect you in a car crash and all that, but sort of a little bit more mathematically speaking, to increase the amount of time it takes you to come to a stop. You as in your actual body. Amount of time it takes you to come to a stop. We can't control the force of the crash, but we can try to control slow down that time, okay? So if you have more time, that's going to equal less force, so that's going to be safer for you, okay? So kind of looking at this, if you think about it, you would have a small to the left saying small force times, right? Because impulse is force times time. So I should make that still left. Times a big letter T. So you're trying to increase the time. So airbag increases time. So that's the job of the air. Now, of course, it can only do that so much, but it's the idea is that it's going to take longer, and that therefore will helps protect you.